Hey, hi everybody. Good evening. Just guys, anybody let me know that did you guys received an email for today's class? I mean the live class link.
No, Sachin, I don't get any information.
How you have joined it?
Uh,
Uh,
when we log into our portal, there will be a common link. So from there only we have clicked and joined.
Yes.
Oh, okay. All right. Okay. Let's have it class. Maybe will not stretch too much. Maybe 1.5 hours. But let's have it. Okay, today. And let me just inform to some more students because somebody have called me for the same thing. So just give me the confirmation to them.
पेपर छोड़ दो।
All right. So I just informed a couple of more folks to join. Uh, I got a 3 to 4 calls. Maybe due to link is not sent and Sudhanshu sir is also on the leave. That's why. Anyways, happy Independence Day, everybody.
Independence Day.
Happy Independence Day.
All right. A lot of people are thinking that today is Independence Day, but sir is not taking a leave. So how is it Independence? Anybody thinking?
Yeah,
Yes.
I,
we are thinking that.
yeah, I mean, I thought Independence Day generally we celebrate in morning, so this class in the evening. So let's have it. I mean, just for 1.5 hour or 2 hours.
Sachin,
Uh,
from 30th of August, there will be an agentic AI batch. So are you taking it only?
Yeah,
from
same.
30th. Yes. It's a new batch we are launching, and it's different than Siddharth, the last batch. We are gonna cover the Google ADK and then AWS Bedrock Agent Core, a lot of new basically agentic tool as well. But yes, it's my course, and we are gonna launch it on the 30th of August.
Okay.
Yep, fine. Let's continue.
Hey, hi Sachin. Sorry, I just joined. You were saying something about the course. Can you come again on the course actually?
Yeah, so we are launching a new course on agentic AI
Mm-hmm.
from 8th of August, and sooner you will also get an announcement video also from our end, from your own side. So basically, it's a agentic AI course, but we are gonna cover over there Google ADK, and then like some advanced concept, stress
Okay.
testing, and then kind of deployment on ADK with the help of Cloud Run and AWS Bedrock Agent Core. So which is not
Okay.
the part of this course because Here it's Gen AI plus agentic AI. There the focus only will be on agentic AI, right?
Okay. Yeah.
Yeah.
Actually, my company uses Google ADK, so it will be
Okay.
good. I will
Oh,
plan to join that one. Thank you.
awesome, awesome. Yeah, we have a plan to cover ADK in a much more detail. I mean, of course, LangGraph is also the plan, LangGraph deep agents, and then of course ADK, and then finally A2A communication, A2A protocol. So those are the plans. Yeah. You can always go through the course, and since it is on live, and you can see the syllabus, whole syllabus is also there. And sooner we are gonna give the announcement video for the same course.
Sure. Thank you.
So some
No
of the
problem.
concepts are also similar like
Yeah.
in this batch, right?
Yes, some of the
Right.
concepts are going to be similar. Yes. For
Okay.
example, see any course for to learn the agentic AI concept, of course they are gonna be same, but here it's, as I said, it's Gen AI plus agentic AI. Over there, the only focus will be agentic AI.
Okay.
Yeah.
That course will be subset of this course.
Kind of, you can say, but you can always like say that I mean, in terms of agentic AI, we are going to cover more and more tools, more and more deployment techniques,
Okay.
which is not be available in this course. Yeah, of course, here we are going to build the agents, we are going to deploy it, but it's going to be on a certain level. Okay. All right. Let's get started. By the way, you can see I'm already preparing the ADK material, so these are those things what we are going to cover in that.
This is starting in August or the one which is announced in October?
It will start on 30th of August. Orientation will be on 30th of August, and then finally from 1st September, we are gonna start the class.
But
After
there's
that,
one more I see on 31st October, like Agentic AI 2.0 something with your name
uh,
and Sudhanshu sir.
wait, which one you're saying? Let me see.
Actually, picture is the same, but name is
This
different.
one you're saying?
Yeah, Sridhar H is name,
No, no,
but
this is not me. This one is the Oracles.
it's look like the same
Yeah,
picture,
its
right?
picture looks same.
Kind
Yeah.
of, kind of same. Yeah, yeah. No problem. Yeah. This is only for the project, and this one is like the whole thing.
So is it advisable to join both because that would be hectic sick hour for
I
us?
mean, you just go through the syllabus, see which one fits your need, and accordingly you can decide. Yeah. Okay. Just give me a minute, okay? Uh, I'm getting a call from Deepesh. Yeah, I mean he's asking the same thing, like is student have joined or not, because it was not conveyed to them for this class that this class got cancelled, right? So he was asking the same thing. Fine. Let's continue. Okay, so in yesterday's, in last class, we have covered till LangChain agents. Sorry, LangChain chains basically. We were able to understand the simple chain, sequential chain, parallel chain, and conditional chain. And that is fine. Now we have to start with something called as RAG. Okay. And we have to cover the, various aspects of RAG. And I have planned it in such a way that let me go and yeah, I think we have, yeah, all the files are over here only. So let me first start the introduction of RAG because it should be from the basics and we should be going all the way up to very advanced thing. So let's start the whiteboard. Okay, so let's try to first, understand the RAG. I know a lot of you guys have already understand the architecture of RAG, but let me put it once again for those who are not very much familiarized with it. So first of all, RAG stands for retrieval augmented generation, right? Retrieval augmented generation. Now, as the name suggests, it has three components, retrieval, augmented, and generation. Let's try to understand how we will build a RAG system, and before that, why even RAG exists. So if I ask you a question, let's say I have a very capable model like Opus 5, whose or maybe Fable 5, whose context limit is 1 million. Okay. 1 million is the context size. And let's say you have a document like maybe 30K context length, 50K context length. Let's say even if you have a 100-page document or maybe 200-page document. So you answer me, okay, this question that do you think in that scenario RAG is required or you just have that model, you give that entire document to that model and it will be able to, if you ask any kind of question on that document, it will be basically able to give you the answer. Right. So just tell me, let's take this scenario. If you have a 200-page document and you have a very capable model like, Fable 5 or Opus 5, do you think that RAG is required in that scenario or not? Just yes or no.
Yes.
Okay. Any reason why?
Because if we pass on the whole document, the context size will be high and even the input tokens will be charged accordingly. Even
Mhm.
though
But
it
but
is
but I
able.
said but I said you have a very advanced model like Opus 5, which has a 1 million context limit and 200 pages PDF is just maybe 500K tokens, or maybe let's say 50K tokens, not more than that. So in that
And
case, your context
yeah,
will not be bloated. Yeah.
yeah, couple of things. It may not be issue with the context, but we will be providing whole document to it. It definitely keeps it in memory, and whenever we try to go for a new session and try to get it again, it will load that complete context for us. In this case, we provide this context. I mean, the document will be in the rack, and only the related content is shared with as a context to the um, LLM here.
You are kind of right. So basically, what you are trying to say is for a given query, the whole PDF is not required or the whole document is not required. For a
Right,
given query to answer it, maybe chunk is sufficient, right? That's what you are
right,
trying to make a point.
right, right.
Okay.
training the
Yeah.
model is also, I think, very expensive, right?
Correct. It's a very expensive model. Yes. So let's now flip
Also,
the question. Okay, let's flip the question and then even try to more understand this concept. So let's say I have a very decent model which is not having a very huge cost. Let's talk about GPT-5. Okay, GPT 5.1 context window. Let's talk about this. Let's see what is their context size. I just want to know the answer directly. So let's do one thing. Let's open a chat GPT. or there is a AI mode also, right, in the Google. Let's ask to them. Yeah, it has 128K tokens. Fine, flagship. Fine. So you see 128K tokens. Let's do some calculation over here. So I'm just gonna assume that, let's say if you have a one I mean a PDF, and let's say this is one page of the PDF. So just for the simplicity and calculation, let's assume that on one page we might be able to have, let's say, maximum 1000 words. Okay, just for the simplicity, we can have less or we can have more, but that's fine. Let's say 1000 words. And by far we know that words are not equivalent to tokens, but again, for the simplicity, let's consider 1000 words is 1000 tokens approximately. Okay, we know that they are not same. Now let's take 1000 tokens, and let's say if you have 100 pages, so basically it will be 1000 multiplied by 100, right? How much it is? Basically 1000 and then two more zeros. Oh, 1 lakh, right? Approximately 1 lakh token. Now, if you compare this to a GPT 5.1, which is having a 128K, so it is in like within the limit. I'm talking about 200 page PDF, right? So it is within the limit. Fine. And also let's talk about the prices for this. So tell me the input and output token price for the same model. Okay, 1.25 and output price is $10. Pretty much fine. I'm not trusting this, by the way, because this might be wrong. We need a source in order to verify it, but let's take these numbers as of now. So 1.25 for the 1 million input token, because always these are in millions, okay? So let's take a scenario for 1 lakh, or let's consider the highest one, 1.25 and $10. So hardly 11.25 for 1 million input output tokens. Fine. Now, this model is not very much costly in that sense. Now tell me, do we require a RAG or not in this scenario? If we have a 200 page document, can we directly not send this entire document to the LLM and we are done? Whenever we ask a question, it will be always kept loaded in the basically in the memory of your LLM or context limit of your LLM, and then we keep asking the question and we will be able to get the answer.
No, because we cannot take advantage of parameters like precision, recall, etc. Like we can make an equilibrium to get a better response in case of multiple identical queries.
Hmm.
So, like which chunk is used, like caching we can use. So that is so there is no need of sending all the data to the LLM itself because of facilities like caching.
No, Siddharth. So the goal of RAG is very simple. You have a document. What you want to achieve is you ask a question and you want a perfect answer on that. For example, if you have a 200-page PDF, you send it to LLM, and if you are able to get the perfect answer, of course, within a less amount of time, your job is done. Now, don't go into the much more technicality like precision, recall. That comes later, but think from the first principle approach. What we want to do, we just want to have our document and we want to do a question answering on that, right? So don't you think this approach will work? I mean, pretty much fine. What's the problem with this approach?
Only one problem.
Mm-hmm.
Latency will be means it will take more time.
Okay, yeah, this is a very good point. And yes, you are right. Latency will be more. The reason is you are sending the 200-page PDF, and in each and every call, this 200-page PDF will go to that LLM, right? Whenever you send a query, you have to send this entire document also to that LLM. Okay, so in each and every LLM call, because now you understand calling an LLM is a API call. when you upload a document in the chat GPT or here, they process it, and when you ask any question, it is loaded into the memory of system, not the memory of LLM. LLM doesn't have any memory. So you have to send the entire data to the LLM again and again, right? So yes, you are right. Latency will increase because every time LLM will process this entire 200-page document. So of course, it will be a little late. So one problem is properly identifiable. Correct. Latency will be more at any given point of time because it has to process this entire 200-page document. So let's assume that in general, if you are getting the latency of maybe 1 to 3 seconds, any idea what is latency in this case? So I have a fair number because I have worked on this situation. It can take anywhere between 10 minutes to 20 minutes. That's how latency will increase for this. So we are sending the only 50-page document to Opus model, and of course we are doing a lot of process in between. And in the Opus model, there is a one parameter called as effort. You can change the effort to medium, high, or max. When we are keeping it to the max, okay, when we are keeping it to the max, it takes this much amount of time. But this is the maximum amount of time it can take. So let's say even if you go for the medium one, right, so it will take somewhere around 2 to 3 minutes in order to just answer your one query. But in GPT model, we don't have those effort parameters. GPT models are a little faster than Opus models. Of course, reasoning wise, they are not, but latency wise. So when we talk about GPT model, so let's say if GPT model with the help of RAG approach where you are sending the chunk data, it takes 1 to 3 seconds versus if you're sending the whole pages. So over there, it might take, approximately, it will take maybe 20 to 30 seconds, something like that. But still, this is a very huge increase in the latency. So this point is valid, Siddharth. Yes, it is gonna have the increased latency. But let's now assume that we are not working on a very crucial project where latency matters much. So let's say you ask a question, even if you get an answer in within 20 to 30 seconds or maybe even 1 minute. Let's take a cap of 1 minute. So if you're able to get the answer in 1 minute, still this approach is simple, right? And we are able to get the answer. Apart from that, like, what is the issue in this thing?
So what I can think of now is we know that, right? LLM also has some size, right? Even if we take the
What kind
lower
of what kind of size you are saying? Context limit, right?
context limit, yes.
Mm-hmm.
Context limit is one of the thing I'm saying. Let's say, acha, there are two ways to access the LLM. Okay. No, I had a different point. I was thinking in a different way. I thought, downloading the LLM and loading it into the RAM memory.
That's a offline. Yeah, that's a offline
Uh,
one. But let's
Offline.
say currently we are using the online models. Of course, if you go for the offline models, in that case, you will require a bigger GPU in order to load it, right? We are not gonna do it on a
Yeah,
local system. So yeah, but
yeah,
but
yeah.
put
I
your, put
was
your
thinking
point.
that.
Put your point. Just put your point.
So my point was, loading the because in order to run the LLM locally,
Hmm.
I need to load it into the RAM memory, right? This is one of
Hmm.
the thing, and along with that, I also need to load this PDF document into the RAM, right? Then only
Hmm.
LLM would be able to do the calculation
Correct.
and prediction, right?
Okay.
So
Yeah.
that was.
Makes sense. But anyhow, like for any use case, if we are going for the offline models, we have to load that into the memory. And yes, let's say if it is offline, then loading model plus loading the PDF is, of course, it's gonna increase your RAM power. You will need a bigger RAM. So yes, it's kind of going to be little more latency. So ultimately, it will come to the latency because even if you have a less RAM, it will work. Latency will increase. So can we say that it is also converging to the point of latency only?
Yeah, yeah, right, right.
Right?
Mm.
Yeah.
One
Sachin,
issue
uh,
I see is multi-user. Let's suppose
I am also working on same PDF. You also working on same PDF. So we both have to upload the same PDF, and we are wasting our context, latency, everything. Maybe RAG would be kind of centralized that if I have a RAG much kind of
So, okay, so let's shift your discussion, Lucky, on the online models. Okay, let's not now consider the offline models. We are not talking about the offline models.
yeah,
Let's
online
think
model.
about the
Yes.
yeah. So even if like now you're saying that okay, if multiple user will come and they will upload the same kind of PDF, 200 pages, 200 pages, that's totally fine because you see each and every call which you are making to the LLM, it's independent of each other. So it's just a separate call, right? Nothing will happen over there. So of course, when you have a multiple user, they are gonna make the more and more calls, and your price will definitely go high because now each and every call will send this entire 200-page PDF to the LLM again and again. So one thing is for sure that your price will go very high. Price will be high when multiple user will come together for multiple users. Uh, that's right. Okay.
We
What
can
else?
also lose of context if we continuously keep asking the questions here, right? So as a
No, you can't maintain the context. I mean, there is a one provision called as prompt caching, but
yeah.
since we have not touched on that part, let's forget about as of now.
No,
Okay.
no, I'm talking at the very high level. In the session, right? We uploaded the document.
Mm-hmm.
Let's assume it is taking 1 lakh tokens here, and we
Mm-hmm.
continuously keep on having the conversations on top of it. To one
Okay.
to one extent, it will uh, almost fill the context, and it will try to ignore
Uh,
the previous
yes.
ones, right?
Yeah.
So
When
in
you
this
when you
case,
keep on
we
asking
will,
the questions. Yes.
yeah,
Yes. Yeah, you are right.
one drawback
So
is
correct. Correct. So yeah, third drawback is also right. So when you let me write it over here. Of course, when you have a very longer session and when you keep asking on like question and if your model has to refer the previous conversation also, in that case, of course, one time will reach where your context will be bloated. Okay. So, but this is only happen for a longer period of time. If you are having a very short conversation, it won't happen. So yes, this is a valid point. It will happen. Right. Um, Anybody have any other point? But now tell me, can we like let's say can we say that if we have a smaller session, we can completely neglect this point? And then if we are working with a kind of system where latency is not that much important, we can ignore this latency part as well. Price is always going to be high, so this is I think one of the crucial point in my opinion till now. But there is something even more important which nobody is talking about.
Sachin,
So let me. Mhm,
I think there is one point, like in case of production setup. So if
mhm,
say the document is like a FAQ or
mhm.
something like that, so if it is updated, it's getting updated every day or
Spot
once
on.
in a
Spot
few
on,
days.
sir.
Yeah, so
Yes,
then
yes.
it will be the problem. So that's why we need one point here.
Correct, 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 Siddharth. So that's what I'm talking about. So let's say this is your data, and Siddharth is pointed correctly. Let's say this is your data document, and let's say the nature of data is changing continuously. Meaning, let's say we have built a rack system for maybe our internal company policies, and you see policies are keep on changing. So let's say if this policy got changed, now if this policy will change, then what will happen? We have to replace this document, and then this new document will come into the picture. But even if you change this document with the new document, there is no like problem in that. You can just take this new document, people will upload it and keep asking on this question. But the thing is, you see, um, LLM inherently does not have the access to your document, right? You have to basically upload this document and then you have to ask it. And these are the problems which we have already seen: latency, price, and context bloat, which is fine. Now let's try to understand the RAG part, what it does actually, and why sometimes choosing a RAG is little, you can say, good option if you have a really constraint on the price and then latency as well as your context. So the architecture of any RAG will simply look like this. You have two things. One is your ingestion layer, or you can say ingestion pipeline, and one will be your basically retrieval pipeline or layer. Okay, now let's try to understand what happens in the ingestion layer and what happens in the retrieval layer. So let me just draw a quick block diagram. You will have your data. Now this data can be any kind of data. Maybe it can be your video data, audio data, PDF data, HTML files, anything, any data it can be. In the RAG system, what we do, we take this data and we try to, first of all, create the chunks of this data. If the data is huge, let's say if you have 100 GBs of data, which will not fit into the context layer of the LLM itself. Does not matter how big your context limit of your LLM, because currently the maximum we have are 1 million. But what if your data is having 10 GBs of data? Simply you won't be able to feed it into the LLM. And that is the first point where LLM comes into the picture. Now we have this data, so of course we need to do the something called as chunking. Now there are multiple strategies in order to chunk this data. We will see it, but overall what we are doing is basically chunking of the data. How to do the chunking is separate topic. We'll talk about it. So once we have the chunking, the next picture is, or the next block is basically you take any kind of embedding model and we have to convert this data into something called as vectors. Okay. So this is your basically vectors slash embeddings. Okay. And once you have this embeddings available with you, we are going to simply take any kind of vector store. Of course, there are multiple type of vector stores and vector databases, but we are going to take any one of them and we are going to store it. Now, the strategies are there how to decide which vector database, which embedding model to choose, which chunking technique to choose. We'll talk about it. And this is your ingestion layer. That's it. Your ingestion layer is now ready. You have build your ingestion layer and now you have to go for the retrieval layer. Okay, so till here our vector database is ready. Now what we have to do in a retrieval layer, there is going to be let me draw it over here. Let's say this is your user. I don't know how to build a user, so let's take this, and this user is gonna of course ask a query. So we'll have a query here. Now this query will go to this same embedding model which we have used over here. And point is the embedding model should be same, not a different embedding model. So we are going to use the same embedding model over here. Embedding model. And again, we will convert that query into something called as vectors or a vector format. And then we'll take this and we are going to hit this particular vector database. All right. And this vector database will give us some similar documents related to this particular query. Okay, similar documents related to this particular query. So in general, we call it as a top K chunks or top K documents. So let's name it top K chunks. Once we have this top K chunks available for us, we are gonna use something called as prompt template. Okay, And in this prompt template, we are going to feed these top K chunks as well as the actual user query. Okay, not a vectorized format, but the actual user query. And by the way, now this particular step, which you are doing over here in the prompt template, this is called as augmentation. Okay. And that's why in the RAG, you have something called as retrieval. So here actually, by the way, I have given the different name of the layers, but you can anyhow change it. So let's call this first layer is as a retrieval layer, and let's not call this as an ingestion layer. You can call retrieval and then another layer, this below layer, which we will talk about as a generation layer. Okay, generation layer. Fine. So this part which you are doing over here, you are taking your top K chunks, your query, and what you are doing essentially, you are augmenting your prompt. Basically, you are crafting your prompt, and that process is called as augmentation. And then finally, you are gonna send this entire prompt template to an LLM in order to get the answer for your query. Okay. And basically, an LLM will generate the answer. So that's a typical flow of any kind of your RAG thing. Of course, there are multiple strategies. So let's say people will start adding the re-rankers over here. People will start using multiple chunking techniques. People will start doing something called as hybrid query instead of normal your vector search query. We'll see all of them one by one, but this is a typical flow, right, of any RAG kind of system. So now if you compare this one with the earlier approach which we're having, so here you see the top K chunks means you will always able to get a very less number of chunks from your data, maybe top 5 chunks, top 10 chunks. So you are sending a very small amount of data from the GBs of data to your LLM along with your query in order to get the answer. So here it's a very cost effective thing. Now, whenever let's say a new data will be added over here, let's say if you keep adding a new data, what you have to do, just you have to create the vectors for those new data set, and then you just have to update your vector db, and this layer will not change. This layer will keep on working as it is. Sometimes if your data change, let's say earlier if you have a PDF with no images, but now you have a PDF with images, in that case maybe sometimes you have to change your embedding model itself, because your embedding model is not smart enough to capture those images. And I have told you that we have something called as multimodal embedding model as well, right? Now each and every component which you are saying, they are basically based upon experiment. So depending upon the problem statement, we have like a lot of option. Each and everything, all of these blocks can be changed, okay, can be played with or can be experimented with in order to achieve the result. So with whole of this discussion, my point was why RAG is important. First of all, I mean, why even RAG exist? Anybody have any question why RAG exist, or still like anybody have like doubt why RAG exist? Are you able to answer this question? Why even RAG exist on the first place? Anybody? Any question?
So what I
Okay.
understood, it's mostly I see a context reduction mostly. And second, I think it would less hallucinate because now we are giving some pointed context to LLM. Previously, we are although giving the PDF, whole PDF, but it may now we're giving this what user asked. We only gave that much to understand.
Okay. Second point, I'm not fully agree, because if LLM is smart, it will figure out what chunks to pick in order to answer the user query if it is able to see the whole PDF. But that's a separate point of discussion. But yeah, your first point is right, context reduction. Now, this is a very cheap process, right? You see, creating the embedding, it's a very cheap process. You take any big document, it will just hardly cost you $2, $1 for even if you have 1,000-page PDF or maybe 1,000-page PDF. Doesn't matter. So embedding part is very cheap. And then finally, you are just sending a very small amount of data to the LLM. So inferencing will also become cheaper. So RAG is basically gonna reduce your cost. That is the first thing. And of course, if your data is not gonna fit into the context limit, like as I said, GBs of data, in that case, there is no option, right? You have to go for the RAG. But there is one more alternate way also, and that is called as fine tuning. Let's talk a little bit about on that. That why we can't go for the fine tuning, or because always people ask RAG versus fine tuning. So what is the difference between them?
Sachin, I have one doubt.
Yes, please go ahead.
Yeah, as you said in the previous question, you asked like which thing is better. So for the data, if we have to update, you said that we need RAG. Okay. So I am asking here the flow which you have explained. Let's say if we have given the updated document to the LLM model instead of DB, we are giving directly to the LLM model. So what is the harm in that giving? Like we do want see, there are obviously internal policies that we need to update. Okay. So my point is keeping data in the database or giving that data directly to the model.
So that was
yeah.
let me clarify that. That was just one part of the equation. Of course, if your data is keep on changing, it's easier to directly give to the LLM and your job is done. Here you have to do an additional task. You have to take that new data, chunk it, embed it, and then save it into the vector DB. So you are right. In that scenario, it's just you have a updated data, you feed it to the LLM and you are done. But now think of in this way that your data keep on changing, and let's say, if you append new pages in your policies, or maybe let's say currently you have a policy, but now you have to add maybe some other documents and then maybe some other documents and then maybe more documents on top of it. So basically you are not updating a data, you are appending the data. So in that case, there will be a point once again that your data size will increase so much that it will bloat your context limit. And hence, over there, once again, RAG will come into the picture. You got the point?
Yeah, okay. Like for one example, I want to ask just to clarify. Let's say if we have a stock data and we have taken a stock data from 10 a.m. to 3 p.m. Okay. At that particular time period, the market was on bullish phase. Okay. But suddenly at 4, some news came due to that thing, particularly the whole market goes down. Okay. But due to like the data which we have given, okay, so that was at that time it was bearish. But after 5, the market goes, reverse. The data which I have given was bearish, but after some time it got bullish. Okay. So in that case, let's say I have given the data of bullish, but my API, like my LLM will call the open API.
Yeah, when you are gonna ask the question, you will get the reverse answers. That's your
Yeah,
point, right?
yeah. So my thing is ki LLM will directly, if I give a access to, the Google API or somewhere stock API, let's say this finance API, so it will automatically update my things also now, because it will have a access of those things also. So in
So
that case, do I need to increase my data size or like that? That is my
yeah,
concern.
so the use case which you are considering over here, there is no requirement of the RAG itself. You can anyhow have a Google API connected to your LLM basically as a tool, and then you will get the answer directly. You don't even have to go for the RAG. But the use case which we are talking about here, it's like when your data will keep on changing and if it will keep on increasing so that it will reach to your context limit. Okay, in that case, RAG will be there in order to use it. Otherwise, if you have, let's say, just maybe 1,000 line of data, why do we even need a RAG system? LLM alone can handle it, right? You just take that 1,000 line, send it to LLM, it will give the answer. That's it.
Yeah, for the basically updation of documents and the context size, it should not increase.
Ultimately, everything boils down to the context limit. That's the essence of the RAG. Okay.
Okay.
Yeah. If you are having a data which is not fitting into your context limit, there is a situation arrives, or there is an option to use RAG. That's how I define it. If you have a something which is within the very context limit, and let's say 1000, 2000 line, don't use RAG. Directly feed that data to the LLM. But let's say if you are having a data which is way more than the context limit or near to context limit, in that case RAG is a good option.
Okay, understood. Thanks a lot for clearing.
Yeah.
One question. Do we delete data from vector DB? Let's suppose I have a policy version 1 and got version 2, which is totally different. So do we
You
remove
can
the
do that.
old data?
Yes. Yeah, you can do that. Because whenever we create a vector DB, it comes with the index ID. It's a database, right? So the same operation which you can perform on the database, same thing is applicable on the vector database as well. So you
But
can do that.
it is advisable, because if user send me a state query that I need a policy, so my DB can give the old data also. So is it should be done?
It depends upon your situation. So if you want to show the older data plus new data, keep it. If you don't want to show the older data, you just delete it. So in system design, nothing is advisable. It depends upon the situation, what you want. Okay.
Sure.
Yeah. All right. Now let's come to this point. Yeah. Anybody have any question? Yes.
Yes, I had one small query.
Mhm.
I wanted to inquire. We have something called as prompt template. Here, anyway, we are giving the top key chunks what we have got from the vector DB after the flow has
Mhm.
gone from the user query embedding model vector and vector DB. But
Mhm.
why prompt template would require top key chunks as well as the user query the user has given initially? I didn't
What do you
understood
write?
that part.
What do you write in the prompt template?
Uh,
Tell me.
uh, I do not know about it.
That's why I think you're asking the question. Have you attended the previous class where we have talked about the uh,
Yep.
let me show you this one. LangChain prompts, where we have talked about the prompt template, chat prompt template, right? Have you attended that class?
Yep, I had attended, but I forgot. Sorry.
Okay, no problem. So you see the basically what we do over here, whenever you send this top K chunks and your query, now along with that you have to say like some kind of system instruction also you have to send to LLM, right? What it has to do with those top K chunks and this query, where you will send those instructions. So we'll send it, we'll put it into the prompt template, what this LLM has to do with that query and with these chunks. So those instruction where you will give in the prompt template itself, right? And then you
Yep.
will send it to the LLM.
Yep. Yes, fine.
Yeah.
Yep, got it. Thank you.
Yeah, no problem. Okay. Now let's talk about, RAG versus fine tuning. So now we know like why RAG exists. So if you have a huge context, of course you go with the fine tuning, but sorry, with the RAG, if you have a very huge data. Now somebody can also, argue that, all right, I have a huge data. Why not, fine tune the model so that I will have the new data also given to the LLM. And the answer is yes, you can do that. And by the way, fine tuning means you are gonna take your actual LLM itself. Okay, you are gonna take your actual LLM itself, and on top of that, you are gonna do some kind of training, and that some kind of training is called as fine tuning. We are gonna do that on one of the model in later class, but yeah, this is what the essence is. You take your train model, and then you are going to take your data, apply some fine tuning so that you will be able to give the new cutoff date to your LLM. And yes, it is possible, you can do that. But the problem is, let's say, what if the data will once again change? So let's say you have this data version 1, okay, data v1, and then when you change it to v2, now once again you have to do the fine tuning. And let's say if you change it from v2 to v3, again you have to do the fine tuning. So somebody will say, okay, then what's the problem? We will keep on doing the fine tuning. What's the problem in that? Problem is, fine tuning is not a very simple task. You will require a lot of compute power, and this will be wastage of money. And data will keep on changing. You have to keep doing the fine tuning, but data will change on maybe even days, right? So you have to do the fine tuning on maybe on days, and that's not practically possible. So in that scenario, yes, we will go for the RAG. Now, but somebody can also say that, okay, in the RAG also, whenever a new data will come, we have to do the chunking, embedding, and store it to vector DB. Yes, you have to do it, but comparatively, it's just it's a pipeline. So you can write this pipeline in such a way that whenever a new data will come, you just hit one single button and that's it. This entire process will be done within few seconds, okay? But, and of course, since fine tuning also can be kept as a pipeline, even if you run a single button for fine tuning, it might take maybe hours or maybe 30 minutes, 40 minutes. And on top of this, you will require a huge infra. You will require a GPU in order to do the fine tuning. Without that, it won't be possible. So fine tuning will be, at any given point of time, it's a costlier process, right? Because you are actually doing what? You are actually tracking your LLM and you are doing the training. And as you know, in LLMs, we have billions of parameters. And let's say, even if you are changing 1% of it weights or parameters, it will take some time and it will be a costlier process, right? So that's why with changing data, people always prefer RAG, okay, instead of fine tuning. So I hope that point is clear. But now let's talk about, so why does fine tuning at all is given at first place if we have a RAG? Is there any situation where we should apply the fine tuning? Yes, there are situations. Let's talk about it now. So let's say you are building a kind of, maybe, let's say, a chatbot. Okay, let's say we want to build a chatbot, but this time the chatbot I want to build is in such a way that it is only want to answer, or maybe let's say the owner of this chatbot want to answer, maybe let's say in Hindi. Now the question is, okay, fine, if chatbot want to answer in Hindi, that's totally fine. I can take a LLM like GPT-5, which understand Hindi, English, anything. So why not RAG? Now here is the thing, not only in Hindi, but let's say I have a very custom constraint on this. So let's say my users who are going to interact with this chatbot, they only know 300 fixed words, okay, 300 fixed words in Hindi. They don't know more than this 300 words. Let's say this is a very unique constraint. Okay. Now, if I use a simple LLM and this RAG thing, in that case, what will happen? Of course, since GPT kind of models, these are multilingual in nature. They understand Hindi, English, everything. But there are high chances they will give the answer which is not in my vocabulary. But this is my need. I only want the answer to be generated within those 300 words. So it can give, maybe use 301th word which is not available in my vocabulary and people won't understand. So this is a limited constraint. Okay, so this is the first thing. Let me write it over here. This is the first point. Second point is, let's say I also want the tune, or whenever this chatbot is answering, it is answering in some kind of tone, okay, some kind of tone, meaning I need this particular chatbot to be empathetic, or maybe some kind of tone which is by default to be set in this LLM. Okay, so in that case also fine tuning is a better option instead of using the RAG. Now somebody again argue on top of this also. Okay, fine. You want to perform maybe 300 fixed words in Hindi, fine. And you want to keep the tone maybe in some manner. Fine. So let's take a bigger LLM. Let's take a bigger LLM, and in the system prompt, let's provide this 300 words in the system instruction itself, that whenever you are going to answer, you have to answer in this 300 words only, and your tone is always going to be in certain format. And since you are going to feed into the system prompt, it will always remain with the LLM, and your job is done. You don't require a fine tuning. And the argument is perfectly fine. We can do that. We can totally do that because LLMs are smart enough. They will be able to understand, okay, they always have to answer within this 300 limit and within some kind of tone, which is fine. But then there is a third point. Okay, there is a third point. Let's say I check this criteria. Let's use this. Yeah. It is able to give me 300 words with some certain tones. But let's say now, I want my LLM to be parametric aware, meaning if I give any kind of data, let's say this is my data, and what I want is, I want my LLM to be really have the knowledge on this data. So when I say knowledge on this particular data, meaning it should update its weights and biases in order to truly understand the pattern of this particular data. Okay, so in that case, you cannot do it with the help of just in the system prompt. You have to really update the parameter of your model. Meaning what? Let me take one example. So consider a LLM. Consider you have a LLM which, let's take a Fable 5 as of now, and or any LLM. But I'm just giving you one example. Let's try to understand with this example. So let's say this LLM is not very good in maybe neuroscience subject. Okay, neuroscience subject, and we can take any example, and this is just a pure imaginary scenario I want to create over here in order to explain you this data patterns to you. So we are considering this neuroscience subject, but it can be anything. And what I want is, let's say I'm an expert on neuroscience subject, and maybe I have written a lot of books on neuroscience. I have a lot of materials, and I have curated all of those books, and I'm calling it as a data. Now, if I feed this data to the LLM, since LLM are, of course, they are smart. If I feed this data to the LLM as a RAG, and when I ask any question, they will be able to give me the answer. But, just consider that maybe, I have done some kind of research also, and I have kept my research paper also in this particular data. Now, of course, if I ask any question, LLM will be able to give me the answer. But, I want my LLM to not just give me the answer on top of it. I want something to be, some kind of patterns to be find it out from this particular entire data. Because I have a research paper, I have a lot of findings in this data. You see, maybe I'm working maybe from 15 years in the neuroscience domain, and based upon my experience, I have curated this entire data. And now what I want, a engine which can go in this data and find some unique patterns, some kind of new patterns. Because let's say if it finds some kind of patterns in this data, it is very much possible that it can do something new, or it can invent a new maybe drug formula for me. I don't know. Okay, and if this is the use case, so in that case, you take your existing LLM, and you are not going to use the RAG, because RAG is, you see, you are just taking your data and chunking it and giving it to the LLM. You are never, taking this LLM, opening it, and changing its weights. And by far, when I say changing the weights means you you are not forcing your LLM to find it out multiple you can say patterns in this data, right? When I say we are training the LLM, you see when those weights and biases will be updated, it also try to find it out the patterns in your data. And if you do that, it might be able to discover some new patterns in your data, and at that point of time fine tuning will become very essential for you. Okay, so in this kind of use case, of course, you cannot directly go to the RAG. Fine tuning is required. So you can consider in this way that if you're going for a RAG, it's a smart solution. Okay, it's a smart solution. Your LLM will be able to only understand your data. But okay, this is true for the RAG. But if you want to discover new patterns in your data, new findings in your data, okay, so in that case, fine tuning is the requirement. So in the fine tuning, we not only understand the data, we discover the new patterns in the data. Okay, and that's where fine tuning will be used. And I'm pretty much sure, even if you have watched a lot of tutorials, or even if you're coming from a very good data science background, you have never heard this term when to use RAG and when to use fine tuning. I mean, a lot of people say, okay, when you just have to have this customization tone or this kind of situation, you can use the fine tuning. But they are not fully right, and I should not say that they are fully wrong also. Yes, for this kind of use cases also, you can use the fine tuning, but now LLMs are so much smart that you can put this entire thing into system prompt also and your job will be done. But still LLMs are not that smart that if you just show them data without changing their parameters, they're not going to find the new patterns in the data. They are just going to understand the data. And when you have to discover new things, new patterns in your data, of course there is fine tuning option available. And on top of fine tuning is what? There is something called as training, which we have already seen, right? And by the way, training is also called as pre-training, because you see there is something called as fine tuning. So on top of training, you can do the fine tuning also. That's why training is also called as pre-training. So if you want to maybe if you have a lot of data, you can train the LLM from the scratch itself. But if you don't want to do that, if you want maybe just fine tuning on top of your data, because LLM is already knowing the normal things in a neuroscience subject, but on top of your data, if you want to just find or discover new patterns, you can always go for the fine tuning approach. I hope it is clear for everybody now why and in which scenarios fine tuning is helpful and in which scenarios RAG are helpful. If you have any question, please ask.
Basically, we want to play with the data, like we want to see how much data we need to update or like that. In that case, fine tune, we should go for fine tuning, right?
No. If you want to discover new patterns in the data, then you have to go for the fine tuning. You said it in a wrong way. You said if you have to play with the data, so you are playing with the data over here also, right? In the RAG also. If you have to discover new patterns in the data, you have to go for the fine tuning. Otherwise, RAG.
Okay.
So Sachin, like whenever we prefer to do the fine tuning, we know now, right, to discover the new pattern in the data we should go for the fine tuning process. Like so in that case, like all the parameters which is defined
in the LLM.
for the LLM after training, that will rewritten again.
Yes. So not all the parameters. Who is talking, by the way? I'm not able to see your name. Sorry. Manish?
Manish. Yeah.
So Manish, not all the parameters will be changed. Only few parameters will be changed in fine tuning, not all the parameters. Because you see, if you are changing all the parameters, basically you are doing the pre-training. You are not doing the fine tuning in that case. And pre-training is always costlier than fine tuning. Fine tuning is you can do it on maybe 6 GB RAM or 20 GB RAM. That's totally fine. But to create your own LLM from the scratch, which is called as pre-training, you will require very heavy GPUs. We can't do that as a normal human being.
Okay.
Yeah.
Pre-training means like starting from the scratch, and fine tuning means like you have the trained LLM, and then on top of that, whatever delta document you want to train with
Yes.
to LLM. Okay, got it. Yeah.
Yeah.
Thank you, Sachin.
And in this course, we are gonna learn this fine tuning, not the pre-training. Okay.
Okay. Yeah.
Everybody clear what is difference between RAG, fine tuning, why it exists actually?
Sachin, just one question. This, like you told in fine tuning, we get to know the pattern about the data. So, as an example, any example do you have? Like, I'm not able to. RAG also gives us to know what pattern, what all things. If we ask question.
So when I say pattern, so let me give you the example. So let's say let's always try to understand from the pre-training and then apply it on a fine tuning. So let's say you know you want a system where it will be basically when you ask a chat GPT just maybe let's say hi there, and if you want to convert this hi there maybe into Hindi, let's take this example. So since LLM has learned those parameters and weights, remember our this class, like the first few classes. Over there, we have learned like how LLM train itself or how it learns basically to convert from one language to another language or maybe any kind of pattern. So this is just one pattern. Now, let's say if LLM you train a LLM which does not have any understanding of maybe grammar. So it gives you the output, but it always makes some grammatical mistake. Now somebody has come up with the proper grammatical data, okay? And then you take your pre-existing LLM, on top of that, you apply your grammatical data. Now in your data, grammars are hidden patterns, right? And your LLM want to basically understand these grammars. So now on top of your pre-training, when you do this fine-tuning with your grammar data, it will be able to understand those, or it will be able to discover those patterns, grammar patterns also. And then now your new LLM, once after doing the fine tuning, whenever you are going to ask the question, it will able to give you the answer with respect to correct grammars, not the wrong grammars. So same thing I was explaining over here, that let's say if you have a LLM with the very huge knowledge, lot of knowledge, but we are taking one subject, neuroscience. Now I know that LLM is already having the knowledge on the neuroscience subject, but let's say something new happened in the neuroscience. A lot of research paper has came up with, and then people have done a lot of other researches which is yet not available in the training data in of the LLM, because every LLM has some kind of training cutoff date, right? So now let's say this is maybe 10-20 GBs of data, okay? And what I want to do on top of this data, I just don't want to put it in as a RAG, so that I just don't want to simply question answer on this data. What I want is, if, because let's say this research paper is having maybe a lot of formulas, maybe to discover the new drugs, what are the techniques to use, okay? Let's say all those things are available in this research paper. And now what I want is, when I gonna send this data to the LLM, I want to do the fine tuning in such a way that LLM should be able to discover those new drug patterns. And when I next time if I ask something else, even with which is not related to this data, my LLM will be able to figure it out, because it has already seen this kind of patterns in this data. So maybe your LLM will be able to discover maybe new drug idea for you, which is not available in your research paper, but since it has observed that pattern which was not earlier, it will be able to give you that answer. Okay.
Okay, basically when predictions come into pictures, we do the fine tuning and RAG is
Why
just
you are going into the predictions? I'm saying just to discover new data patterns. That's it. It can be prediction, it can be anything, it can be maybe regression also, it can be anything. Just discovery of new pattern does not mean the predictions. It can be anything.
okay.
Okay.
Thank you.
So that's where like actual true power of fine tuning lies. Of course, this for this kind of use cases also like we can do the fine tuning. Okay, this kind of use cases like 300 fixed words, or maybe if you want to change the tonality of your data. In this scenario, also fine tuning is helpful, but this can also be achieved with the help of proper system prompt. You don't have to really do the fine tuning over here. But in today's date, a lot of people are doing the fine tuning on this kind of scenario also. So let's say, if you want to build a medical chatbot on medical data, so you have 2 to 3 page document maybe. You take that document, you create data on top of it, and then you go for the fine tuning so that your LLM will be able to provide you the answer with respect to medical terms. Okay. But that can also be very well set it inside the system prompt, and you can take that data, put it into the RAG format, and from there also you will be able to get the same output. So that's not the real power of fine tuning. Real power of fine tuning lies over here, discovering of the new patterns in the data. Are you able to understand now? Anybody have any question?
I have a general question, like for the rack system, can we use it on the image data set? Or is just
You
okay.
can RAG system can be used on anything, right? Image data, PDF data, audio data, anything. Video data also.
Okay.
Yeah. Yeah, Manish, go ahead.
Yeah, so I believe uh, the RAG is invented because we wanted to overcome the context limit associated with LLM.
Yes,
That was the reason, right?
you are right. Spot on. Because you see, when we were learning the LLM fundamentals, so I told you that people are keep on expanding the parameters, and hence we are having the more and more number of context limit, right? But it's not always going to be true that if you keep expanding the context limit, that means your model is smarter and smarter, right? There is going to be some threshold, and currently it looks like we are having a 1 million context limit. And you see now all the models which are being built, they are not crossing that 1 million context limit. And of course there has to be some reason why they are not doing it. So first of all, training those giant model with the 1 million context limit is a hard task. And let's say even if they increase it, maybe let's say even if they increase it from 1 million to 2 million, then what's the point? Still they have some cutoff limit, right? Because your data can be more than 2 million. It can be maybe GBs, and maybe in petabytes also, because big data can be in petabytes. So that's why RAG is invented. You are right. To overcome the problem of context limit. All right. So I hope now you are having a very clear picture of RAG and fine tuning. And trust me, when I ask this similar question to a lot of engineers, okay, tell me when do you use a fine tuning? So they give me this kind of answer. So they say, okay, fine tuning is required when we want to change the tone of the LLM, and maybe do some kind of custom use case. I said, okay, pretty much decent answer, but why can't we just feed this into a system prompt? Because now LLMs are really smart enough. You can simply put this into a system prompt and you're done. You will be able to basically get the answer. After that, they get stuck because they don't know why actually fine tuning is required. And the reason is very simple, because they don't understand pre-training in a good sense. And remember, that's why when I started my lecture, we started with this training part, right? Pre-training, basically. Over there, I have given you a lot of example. When the parameter changes, what happens, right? We do you remember the equation of y equal to mx plus c? We are learning, actually, we are learning the M and C value. So they are, the LLM or model is discovering the pattern of the data, right? And that's why when you apply the fine tuning, you are discovering the new patterns of your data. And you see, now I connected the first lecture, y equal to mx plus c, and over here with the fine tuning, which is a very hot topic in AI era, but it is related to or connected to fundamental. And that's why I encourage everybody to always focus more on fundamental and then go to advanced topics. Then you will be able to, basically answer any kind of interview question in a, I mean, it's going to be piece of cake. That's the thing. You understood the fundamentally, okay, why this is needs to be happen and why you are right. Okay, fine. So now let's proceed. We talked about RAG. So let's try to implement something also. All right, so this is the folder you have to focus, RAG for beginners. Okay, we have multiple scripts in it. And one by one, we are going to understand each and every layer of the RAG. So first of all, we are starting with the ingestion pipeline. Okay, so basically we are going to take some documents and we'll see how to build an ingestion pipeline. So this is the script which we are going to write it. So let me do one thing. Yeah. Now in this particular entire pipeline, you see, we have a lot of things. One is chunking technique. Another is which embedding model to choose, and then which vector DB to use. So to begin with, I'm going to start with a Chroma vector database, which is a very famous vector database. It's a lightweight vector database. So we are going to start with the Chroma. And now let me just give you the idea how many type of vector database we have. So essentially we have actually two types of vector DBs. Okay. Vector DBs, we have two types. One is called as vector store, and one is called as vector database. Vector database. Now, this is also my one of the favorite question. I generally ask the people, do you, so if somebody says me that, okay, I have used the Chroma DB or phase vector database in their project, I simply ask the question that, do you understand the difference between vector store and vector DB? And now people will start thinking, they say, okay, they are mostly same, sir. They really don't able to distinguish between vector store and vector DB. So that's why it's essential to understand, because going forward, you will hear a lot of terms like Chroma DB, phase, Milbus, and whatnot. So let me just give you a brief, between this vector store and vector DB. Now, the very first statement is true. They are almost kind of same. Vector DB and vector store are kind of similar, but they have some differences as well. So vector store is basically a lightweight framework, okay, to store your vectors. So it's a lightweight, and you cannot do lot of, advanced filtering with the help of vector store, because it's a lightweight. And we want, why this was invented, so that you can quickly prototype your RAG systems and you will be able to implement it. That's the simple thing about vector store. They are lightweight in nature, meaning you can directly use it in your memory, in your RAM, and it's not a truly a database. Okay, it's just a vector store which is a lightweight in a nature. And of course you can do normal operations like a database, but since it's not a fully a database, you will not get all the features of the database. For example, in the database you can have partitioning and those things, whereas vector store does not support partitioning. Of course it supports to store the vectors that functionality it has. You can query this vector store, and of course you can apply some basic filtering on top of it. That's what this vector store does. But when it comes to vector DB, and by the way, what are the example of vector store? So there are multiple. You have Chroma. Chroma is one of them. You have Phase. Phase is from the Facebook. Now, by the way, I think by August 2026, Chroma has implemented its vector DB also, but it is available in the form of vector store, meaning when Chroma was launched, it was only a vector store with few features, but they have started adopted all the features of the vector DB. So initially Chroma was not the part of the like kind of vector DB, it was just a vector store, but now they have all the features of vector DB also. So currently you can say it is in not fully vector store. It has gone into the category of vector DB, by the way. Phase is one of them. Okay, these are few. Then in terms of vector DB, it's a full-blown database, so it supports all the functionality of database. And the examples of these are, maybe you can take example of Pinecone. Pinecone is one of them. Then there is something called as Milvus. Then there is something called as let me see, I don't remember each and every one name. Yeah, there is something called as Quadrant as well. Q Trent. Okay, these are vector databases. Apart from that, our AWS, Azure, and GCP, they have also some vector databases available within that. So from Azure side, you will be able to see there is something called as Azure AI Search. Now, they call this Azure AI Search as a vector store, okay? But they call it as a vector store, but it's not a vector store, it's a vector DB. They call it as a vector store in general, okay? But it's a vector DB, it's a full-blown vector DB. Similarly, from Amazon side or AWS side, we have something called as Open Search. Again, this is a vector DB. And then from GCP side, there is something called as RAG engine. Okay, I think they do not have some dedicated only vector database. They have this RAG engine where you will be able to create the embeddings as well as store it. And we are going to see all of them in this course, so don't worry about it. All right, so these are some example of vector store and vector DB. When initially these libraries were into the picture, the line was very clear. They were coming into the vector store and vector DB, but now the line is becoming thinner and thinner. Now kind of you can say vector store are merged into a vector DB because they also have all the features of database. Okay, but I thought this is important to teach you so that if somebody asks you a difference between vector store and vector DB, logically you can give the answer, but you should also have this knowledge that now all of them have the feature of hardcore database as well. So a line is very thin between vector store and vector DB, right? So we are going to use the Chroma, and in order to use this Chroma vector DB, we need to install this library, a LangChain Chroma. From there it is coming. So let me do one thing. I will install this UV at LangChain Chroma. Okay, done. Now let's try to see this code. So first of all, from LangChain community.document loaders, I'm importing two things. One is text loader and another is directory loader. Now, since we are gonna do this entire exercise of building this entire pipeline into the LangChain, LangChain supports, the lot of document loaders. You can load the CSV file, PDF file, text file, and bunch of other files. And from the same thing, like now, first of all, we are going to understand how we are going to load a simple text file. So that's why we are loading it. And this is the class. It's basically going to help us to load the text documents. All right. And then in the LangChain text splitter, this is another library. When you install the LangChain, it by default comes with that. We are going to import something called as character text splitter. Now, character text splitter is the class which will help us to split our documents into multiple chunks. So we are going to use that. In order to create the embeddings, we are not going to use this OpenAI embeddings because this will charge some money, and I mean I don't have a balance in my OpenAI account, so I'm not going to use this. Let's change it to something else. And yeah, Chroma we are anyhow gonna use as a vector store. Now let me just check my .env file. Yeah, all the API keys are already in place. So let's try to understand this function one by one. So first of all, we are writing a load document function, which is gonna take the documents, a document path, and it's gonna load it basically. So we are gonna provide the path in this function and it will load all of those documents. And by the way, I have a document over here in a docs folder. You see, I have bunch of TXT file. One is related to Google, Microsoft, Nvidia, SpaceX, and Tesla. So these are my documents. And I have one PDF also. And by far, you attention is all you need. That's a PDF. So you are already having the knowledge of that PDF. So we are gonna load these TXT files. Okay. So what I'm doing over here, you see, I'm checking if that path exists or not. If it not exist, it will gonna create that path. And then with the help of this class directory loader, I'm gonna pass the path of that directory, and I'm checking from that directory all the txt files only I have to load. So in this same directory, I have a PDF file, but it's gonna ignore that PDF file because we are loading the only .txt file. So this is just a checker for to load the txt file. That's it. And yeah, we are with the help of then finally loader.load. You have this object loader. When you call this load function, all your documents will be loaded, and we are gonna call them as a documents. And then finally, we are just checking if length of the document is 0. We are gonna return some kind of error. Otherwise, we are gonna iterate through all of those documents. So you see, I'm just saying iterate through first two documents in order to show those documents. And whenever a LangChain will load these documents, it will be available in a LangChain document format. So it will be able to show you the source, content length, content preview, and metadata. That's all. We are printing it over here for the first two documents. And then finally, we are returning these documents. Okay, that's it. So let's do one thing. I'm gonna let's okay, this is the main one. Till here, let's comment the code and let's test this much. ChromaDB is also not required as of now. Okay. Yeah, so we are just checking this function load documents by providing this docs path, and doc folder is available over here. Let me copy the full path, copy path, and let's provide it over here. So this is the full path of the document folder. And let's see what we get. Let's try to print the documents directly. All right, let's run this. CD rag for beginners, and then do we run one ingestion by it's loading the document, so let's wait. And there you go. You see, it has loaded all of the document, the content of the document basically, in a list format. So it is basically a list of all the documents. Let's, you see, this is how it has loaded, which is fine. So we are able to see all the documents are being loaded. Now, once we have all the documents from all of these TXT files, what we have to do, we have to basically split all those documents, right? So here is the next function for doing that. Let me uncomment it. Yeah. Now you see what we are doing over here in this split documents function. We are having like getting this function takes documents. There is something called as chunk size and chunk overlap. So currently chunk size I have set it as 1000. So just give me a moment, guys. Okay, give me. Okay, sorry for that. Let's continue. Yeah, so yeah, we were on this chunk size and chunk overlap. So this function takes the documents, and what we are going to do, we are going to divide the all the documents of chunk size of 1000. And when I say chunk size 1000, so basically 1000 is going to be our kind of all the chunks. One document will have 1000 chunk size. Basically 1000 is going to be your kind of similar to words, 1000 words in a one document. Okay, and there is one more parameter called as chunk overlap. Currently we are setting it as a 0, but there is a role of this particular thing which we are going to explore later, so just bear with me. And then finally, with the help of this character text splitter, what we are doing, we are creating the object of this class, and we are calling it as a text splitter. Here we have passed our chunk size and chunk overlap. So it will give us object text splitter. And within this text splitter, there is a function called as split documents. We are going to send all of the document, and it will automatically going to chunk all those documents, or each document will have the 1000 chunk size, and we'll get all our chunks. And here we are just, printing the top 5 chunks in order to see what it contains. That's it. And then finally, you see, we are returning all of the chunks. That's it. So this function is basically gonna take the documents, chunk it off, and then return all of those chunk documents to us. That's the only task of this function. Now let's uncomment this part also from the main function. Okay, so this is our chunks. Let's try to see how many number of chunks we are able to create it when we do this process. Okay, so you see total chunks created 1330. So these documents are, it's not small documents, you see, it has a huge document around 4,000 or maybe more than that. Yeah, this has almost around 4,000 lines. This is also having almost around some 3,000 lines. So these documents are big enough. And that's why we are able to get the 1330 total number of chunks after doing this, right? And you see the how these chunks look like. For example, chunk number 4, this is how it looks like. It has a source, it has a length, it has a content, and content is the actual content of that particular text. And in the content, you will only see the 1000 sorry, the words, not more than that. Now you see in the fourth chunk, it has printed over here, but in between it got cut off. You see, million and then equivalent to Indian subcontinent, and then it was got cut off, right? Now in the chunk 5, it is starting from, I mean, after that. So after subcontinent, there is 12.5. This information is there and it is continuing from there. Now, you see why this is happening, because it is being cut off, which is fine. But since we set the chunk overlap to be 0, it is starting just after that. So this information is a part of this particular block, but it got cut off because we have kept the chunk size of 1000 only. And this is a bad practice, because you see when you're gonna, let's say, when you're gonna ask the query and these chunks are available finally in the vector database, and let's say if you're gonna ask any kind of query and your vector db will give you, this chunk as a relevant answer for that query, in that case what will happen, you are going to only send the half of the information to the LLM and you won't be able to get the proper output. And that's why we use something called as chunk overlap, so that some information from the previous chunk also will be overlapped to the existing chunk. But currently we have stored it as a 0. We'll experiment it, because these are all experiment parameters. We can always experiment and see in which case we are getting a good accuracy. But that's fine. Let's continue with this setup only right now. So we are able to get all the chunks. Now in this, we are able to do this particular step, chunking, right? Now we will require one embedding model in order to create the embeddings for all of our chunks, correct? So let's do that. Let me uncomment this part. So over here, I'm writing create vector store. So I want to create a vector store or vector DB. So here is the folder path. I'm saying in a root folder, you just create this folder called as DB, and then within that DB, we are going to create a folder called as chroma DB. And within that chroma DB, we will have our vector store available to us. Okay. Now, of course, we need a embedding model, and I don't have a subscription for this one. So let's change the model. What I'm going to do, I'm going to use another set of model. Let me use this Gemini embedding model. So I'm going to copy this and, or let's do one thing. Yeah, copied it. So let's create a common functionality. I will say embedding.py paste it over here. And now we have this class, right? Gemini embedder. And this time, instead of using the Gemini embedding 2, because it's a little more powerful model and it's a multimodal embedding model, and we are just dealing with the text data. So I will use another Gemini embedding model, which is Gemini embedding 1 model. And let's see. What it has. Gemini embedding 001. This is the model code. So I'm going to replace this with this one. Okay. Yeah. So we are going to use this model. So we have our common Pi available, and we can always use this embedding model at any given point of time. So let's go here, and instead of writing this, let me just do this. And we just have to import this Gemini embedder. So I will say from embedding, let's import the Gemini embedder. Embedding spelling looks wrong, so let's correct it. Okay, embedding, and there you go. Now this is our own custom class, right? Gemini embedder. And if you remember we have written this, right? Over here we are just using this from Google, import Gen AI. This is our custom class. In this class, what we are doing, we are calling this Gen AI client, and we are writing custom function for embedding the images and embedding the text. And we are going to use this embedded text, right? Because we are dealing with the text data, not the image data. Now let's come back over here. Ingestion pipeline, where we are using this Gemini embedder. So this is our embedding model. And okay, I don't know whether this chroma will work with this embedding model or not, but let's see. Let's see if this works. Totally fine. We'll see. Fine. So here is our embedding model. And then finally, in order to create the chroma vector database, I am using this chroma class, and then it has a method called as dot from documents. So I'm calling it. And over here, you see what I'm passing my all of the chunks as a documents, my embedding model, with the help of which it will basically create the embeddings and then store it. And then it require a persistent directory. So where this database or data vector store should be created. And then since it works on the collection, so internally you see Chroma is going to use something called a SQLite database in order to create your vector database. So it requires a collection metadata, and you see we need to set this HNSW : space. This is the metadata information of your collection, and by default it is this. And on which metric you have to basically create those vectors. So with the help of cosine similarity, we need to create this vector database, because when we are gonna hit the vector database, if you remember, vectors are nothing but they are, whenever you ask a query, it will be converted into vectors. And then finally, we need to compare this vector to other documents in order to fetch the similar document. And for that, we are going to use the cosine functionality for that, because vector can be comparable with the help of cosine formula. So we are setting that feature over here. And then finally, once this will be created, we are going to just print, okay, this vector store is created. Okay, that's it. Now, let's come over here and let me unblock this part of the code. So over here, you see what we are doing. We are giving this persistent directory, and we are just checking if this directory already exists or not. If it does not exist, let's create it one. If it exists, then no need to do anything. And then finally, yeah, with the help of this embedding model, we are calling this particular class, and we are just basically, yeah, I mean, if it already exists, then we are just calling this, and we are returning the pre-loaded vector database, nothing more than that. So this is just for checking purpose. Okay. Otherwise, we can say directory does not exist, initializing the vector store. Now let's run this. And here at step number 3, we are actually gonna create it. That's why we are calling this create vector store over here, after doing the loading the document, splitting the document, and chunking it. And that's it. This ultimately we are gonna just return the vector store. Why we are returning the vector store? Because it's a main class, main function, and we are calling that main function in this if underscore underscore name, right? So from here we are gonna return that vector store. That's it. Okay. Now let's do one thing. Let's call this entire code in one go and see what happens. Okay, so it started embedding, I think, and yes, it got the error. Gemini embedder object has no attribute embed documents. And yes, it is expecting this embed document. And since it's a custom class, right, we have written this custom embedding model. And if you go to the custom embedding model, you see we have the methods like embed image and then embed text. But what it requires is something called as embed documents. Okay. And we don't have that. So let's do one thing. I will do one thing instead of let me see. I think I don't have to write this custom function. I mean, I can very well implement this embed documents, but LangChain is already supporting the Gemini embedding model. So let me just search it. GCP or Gemini embedding model LangChain. Yeah, this is the class. Okay. So we can directly copy this one from LangChain Google Gen AI. Let's just change this. Let's not use our custom class. Let's use this. Okay. Now this already has, these guys have already implemented this embed documents, but it's just an implementation of class and methods. We can also do the same thing. So let's change it. Okay. And you see, I just now changed with the Google Generative AI embedding, which is a LangChain Google Gen AI. It is coming from there. Okay. Instead of our custom class. That's the only difference. And they have already implemented this method called as embed documents. All right, now let's try it once again. What happened? Vector store already exists. All right. It says it already exists. Okay, no problem. Let me delete this database. You see this folder got created, so that's why it is saying it already exists, and that's why it was not creating it again. So I deleted it. Now let's try one more time. And now you see the database got created, and now it is creating the vector store. Total chunks we have 1330. One by one, every chunks will be stored in this database folder. You see in the database we got the ChromaDB, and within the ChromaDB you will see a file called as chroma.sqlite3. So ChromaDB uses a SQLite in the backend in order to create the vector database, okay, or a vector store. But now they are using the SQLite, so of course you will get all the features of database also. And you see now it's taking time because it is creating the converting it into embeddings. All the documents are converted into embeddings. So let's wait. Once it will create the vector store, yeah, it will basically gonna print this line, ingestion complete. We should have put the log for each and every document. We can do that also, but that's fine. Let's wait. And there you go. We got this ingestion complete. Your documents are now ready for the RAG queries. That's it. And now you see over here, it has this another folder, which is having all the metadata information of your chroma.sqlite. Okay, by the way, we will not be able to see the actual embeddings inside this chroma SQLite, or let me see if we are able to see this. I already have a SQLite extension. It only shows one row. Fine, no problem. But yeah, all our vectors are now available in this chromadb.sqlite file within this folder. And that's it. There we go. Now ingestion pipeline is ready and it's completed. So you see, once you have this pipeline ready, if your data will change, you just have to update your docs folder, and then you can have a check also that which are the documents are already being embedded. On top of that, if new data is coming, you have to just only embed those new documents. So you can have one more check in your pipeline, which will basically gonna embed the new data and not the previous data. But let's say if your original files are changing, in that case, you have to write a condition. If there is a change in the original file itself, then you have to re-embed it once again. But we are not doing that as of now. Okay, but you can always have those logics, okay, in this place, in the same file, ingestion file. Now let's go and just see quickly the retrieval pipeline. Okay, so let's remove this OpenAI embedding because we are using the this embedding, right? Google generative AI embeddings. Okay, cool. So you see what I'm doing? I'm using this model, and this is my persistent directory where my vector database is available. I'm calling this chroma class, passing my persistent directory, embedding model name, and then collection which I want to use in order to load it. And with the help of this code, you will be able to load your vector database. Okay. And that's it. Then you have a query. For example, the query is how much did Microsoft pay to acquire GitHub? This was my query. Now, you see, first of all, what I've done, this is my database. I have in the LangChain, whenever you use this chroma from the LangChain, there is a method called as retriever. So I'm converting my database as a retriever so that I will be able to retrieve the documents from my database. So you have to use this method as retriever. And you see, I'm setting some parameters to this retriever. So search keyword arguments, and I want to only get 5 top documents from this retriever. Okay, So this is my retriever. Now, once my retriever is available, I'm gonna take the retriever, and you see this invoke method. You see from the first class we are seeing this invoke method. Whenever in the LangChain, if you want to invoke any object, you have to use this invoke method. So we are gonna send this query to retriever, okay? And this retriever, since this retriever is coming from DB, and DB is already having this embedding model, right? So this retriever will automatically convert my query into embedding, and then it will also give me the relevant documents. So this part which we have done over here, let's go embedding model, and then vector store. This one we have seen, but this part, our query, we are sending to the embedding model, and then finally once it will be converted into vector, we are hitting our vector DB. So instead of doing in this way, we have created a retriever with the help of DB, and then that retriever is basically doing what? It is taking my query, converting internally into a vector format, and then giving me these top k chunks, right? So this part is done by this retriever itself. All right. So we have this relevant docs, and then you see what I'm doing. I'm just iterating through these relevant docs in order to see the content of it, because you remember the way LangChain is gonna put it into a split format. It will have the page content, it will have the source. So I'm just checking the page content of the document. All right, so let's try to see, are we able to retrieve any relevant documents or not. If you're just gonna purely write the print the relevant documents, you will see bunch of other things like sources and all those things. Okay, but I just want to see the page document. That's why from the document I'm extracting this dot page content. So UV run to retrieval pipeline, and let's see. And there you go. So user query was this: how much did Microsoft pay to acquire GitHub? This is our document number 1, which has some information, fine, not a problem. Document number 2 is this one. Document number 3, 4, and 5, right? And when you read it properly, it has some information where they are talking about, the acquisition of GitHub for 7.5 billion and whatnot. But these are all raw information. We still have not sent this data to LLM in order to produce the final answer. Fine, but we are able to at least get some documents, and this process you have already seen, right? In when I taught you the embedding class. Over there, the same thing we were doing, but it was happening purely based on embedding. We were not using any vector database, but now we are using the vector database as well. Okay, fine. Now, let me also print the source of it. So let's try to print the sources as well. And there you go. So you see, for each and every document, it has printed the source also. So document number 1, and then its corresponding source. So it is coming from Microsoft.txt file, this one. The first document is coming from Microsoft. Second document is also coming from Microsoft. Third is coming from Microsoft. Fourth is also coming from Microsoft. Fifth is also coming from Microsoft. So meaning in the Microsoft document, it is more talked about how they have acquired the GitHub and what was the amount. Okay. So this is how we have built the retrieval pipeline. And now we have to go for the prompt template and then sending to the LLM, but we can stop over here for today's class. And we'll continue in tomorrow's class. If you have any question, you can ask.
So, in the embedding model, so suppose we have divided the code. Like initially, when the document was chunked and converted to embeddings, we used one particular embedding model. And later, while we retrieve the query, we use another embedding model, maybe of same dimension.
Mm-hmm.
It
It
will
won't
work, right?
work. It won't work because embedding model they works. Of course, dimensions should match, but apart from that, every embedding model has their unique style of converting the words into the embedding. So they are trained on a different words. So if you are using some embedding model to create your embeddings, basically chunk your document and then create the embedding, same embedding model you have to use while converting, I mean, your query to those embedding model. Otherwise, it will work, but there is going to be discrepancy in the output because see, what you are trying to do is basically you are using two different model in order to first ingest it and then finally get the answer from it. And since they are trained on a two different set of data, right? Every embedding model are trained on a different set of data, you will get discrepancy. So that is not advisable at all. You should be using the same embedding model. Mathematically, if you ask me, it will work, but logically, this is the answer that since they are trained on a different set of data set, you never know which why sometime it will start giving the wrong answer. So that's why you should always use this same embedding model while retrieving it and while generating the embeddings both.
Yeah, got it.
Yep.
So Sachin, will it be right to set for this question, the vector number is different for different words for
Yeah,
different
yeah,
embedding?
yeah, yeah, you are right. Vector numbers. So basically, those numbers which we get in the vector format, they are going to be different for different embedding model.
Done.
You are right. Yeah.
So Sachin, like currently we are trying to build a pipeline for TXT files.
Correct.
So let's say like we have some company documents and there is like a lot of diagrams and machine designs,
We'll
let's
we'll
say.
we'll come to it. We'll come to it. Don't worry about it.
Okay. Okay, because like there are like a lot of images or something like that. So
You
how
will
can
you will see this is going to be your a rag, a kind of rag course where you will go from very basics like text files to all the way up to very complex files. Don't worry about it. And you after this class, I mean after completing this rag thing, you will not require any tutorial or anything on the rag. Trust me.
Oh,
At least till cutoff date, because a lot of research are happening, of course. So maybe
yeah,
you will
obviously.
not end up seeing the same thing. You will search for the new things after completing this class. Okay.
Yeah, okay. Okay, perfect.
Yeah.
Yeah,
We'll
thank
do
you.
that. Yeah. Any more questions? Anybody?
I'm having one question. In RAG projects, why do we use LangChain? Means without LangChain also, can we develop projects such kind
Yes,
of?
you can do that. Yes, you can do that. So it's not about only RAG. You take any Gen AI thing. LangChain is having a rich ecosystem. They are already giving you some wrappers in order to write a less number of code. That's why we are using LangChain. If you have any other good framework, use that. Not an issue. But in this course, I have decided to use the LangChain. Two reasons. In interview, a lot of people ask about LangChain. Second thing, it has a wrapper in order to write less number of codes. That's why. But you can
Okay.
use, yeah, you can use your custom class. You can use any other framework. I don't have like any problem in that. You can use that.
Okay. So I wanted to know what the code changes will appear like. How will I get to know here we have used LangChain, here we have used any other framework like that?
By looking into the code, you see we whenever we are importing any class, if it is a part of LangChain, over there you are using LangChain. If it is not a part of LangChain, it's not a part of LangChain. Simple. I mean, what
Okay.
kind of
Means just by
question?
looking at the initial part of code, we will get to know it.
Yeah, see, ultimately code is what? It's just a object and class, right? So
Yes.
whenever you are creating any class and object of it, Just check whether that class is coming from where, whether it is coming from LangChain library or not. Simple. You
Okay,
see,
okay, got it.
this class is coming from where? This class is coming from LangChain. So yes, we are using LangChain. If it is not coming from the LangChain, we are not using LangChain. As simple as it is.
Okay.
So with the help of LangChain, uh, we need to write less code, and we can achieve more functionality. For example, if I
I mean,
understood
that's why.
correctly, yeah.
Please go ahead. Yeah.
Yeah, so I understood during the retrieval, we convert query to embedding, and then we pass it to vector DB, and we also fetch top chunks, and then we compare how similar it is with the this thing top chunk cosine similarity I'm referring here, right? And with that we are finding, okay, what is the best maybe the answer suited for that question, something like that, and we write the LangChain code for achieving these many things through one single. I have seen something in your code. So I'm more interested here, Sachin. Um, how to find how we would know, okay, this particular command will do these many things, like you're showing it here, right? I understand, but if I'm going to write new code and I
First
need
of all,
to.
okay, let me answer that. First of all, so let me answer the previous question to that person. Why LangChain is required? I think you got the overall answer. See, why we use any framework? LangChain is what? It's a framework. It's a Gen AI framework. Why we use any framework? Why we use React, right? Why do we even use Python? I mean, why not to write a code in assembly language? Have you written any code in assembly language? Anybody over here?
Yeah, I have written during my
Okay.
engineering. Yeah.
Yeah. I think most of us have written the code in assembly language in the engineering. So why to use Python? Why not assembly? Because ultimately this code are converted into assembly language, and from assembly language it got converted into 0, 1. So why not directly write it in 0, 1s? Why do we need Python only? Why not to just type
This
0,
this
1,
is
0?
this is not human friendly to write it in
Simple, no?
assembly.
So any framework, why they have created to just write less number of code. They have giving you already pre-built classes, pre-built methods to use it. So next time this question should not come to your head like why to use any framework. Yeah, like why to use any specific framework, that should be your question. But why to use framework, this should not be a question, right? So that is one thing. And then second, yeah, coming to your question, how you will be able to know like in LangChain what classes to use and how to use them. So see, whenever you learn new things, of course, you will not be knowing the all the part of those new things, right? So what I'm doing when I teach all of these things, and once you will be equipped with the syntax of the LangChain, uh, you can say universe, then all of these packages you are now get familiar with all of these classes, right? And then whenever you have to do research, you will just simply go and search on the internet, like, okay, let's say you want to implement maybe MCP in LangChain. What you will do, you'll just say MCP LangChain. That's it. You will get the documentation, you will see how to use it. As simple as it is, right? This is one approach. Other approach, you don't know anything. Let's say you are a you are very dependent on maybe your cursor or maybe something like that. You use open maybe anti-gravity, or maybe you open anything. So whatever you are using, any ID, you go and ask, okay, I want to implement this in LangChain. Maybe I want to implement MCP server, I want to build MCP server in LangChain. Give the instruction to your AI. Your AI will give you the code. Now just go and read about that code, right? And then try to match it with the official documentation of the LangChain. Okay, so that is how the usual process is. Whenever you are learning any new framework, initially you will not know all the classes and all the basically what are the different classes they have implemented. And by learning any new framework means what? You learn all those their classes, right? And get the overall idea. And then if you have to implement something new on top of that, you can use their existing classes once you know it. So it will come by practice. When you look multiple number of codes in the LangChain, then only you will get to know, okay, these are the classes I have to use. There is no other way, right? I mean, you tell me, na, how you learn any new thing. Maybe first time.
Understood. Understood,
Yeah.
Sachin. Understood. Yeah, yeah.
Yeah, so these are
Understood.
very basic kind of question you guys are asking. Maybe, let's say when you started Python, you don't know about what is object, what is class. So how you learned it? You first learn it, and then now, since you have the power of AI, you can simply ask and then get the answer back. So that is how learning happens.
One more thing, Sachin. We convert the long text into chunks, and then we are storing it into vector DB. Is it like the whole chunks is converted into a vector, and that is something gets stored into a vector DB? Uh, like it is similar to SQL database where
Kind
we
of. So yeah, kind of. So the way it gets stored is in this way. So for example, let's say this chunk number 4 or document number 4. So for this document, it will be first of all converted into a vector format. So, and that this document will have some document ID also associated with it. And then since it's a SQL, right? So it will store the data in a tabular format. So you will have in one column your actual chunk content. In the next, its corresponding vector DB, and next corresponding to it, its document ID. So like these three columns will be maintained in this SQL database file.
okay.
Yeah, in this chroma.sql, yes.
Like, is it faster SQL database, Sachin?
SQL, see, in terms of faster and not faster, generally, you see, here it's a one-time process, right? So even if you, let's say, creating millions of chunks, you just have to store it in once, right? And then you just have to query it. And while querying, you are gonna do the query based on similarity search, right? So you will have those vectors. When you are gonna search, it will basically compute the cosine similarity, and since it's a formula, it can do pretty faster, right? It just have to calculate the cosine of your vector and with millions of vectors. So in that case, it will be fast, but yes, there is a trade-off. This is not too much fast when it, let's say, when you scale it up maybe for billions of vectors. In that case, there are other databases which we compared. So this chroma is never gonna be used in the uh, production, I would say. But see, it also depends upon your use case. Let's say if you are having maybe just 10 PDF documents, and on top of that you want to build a RAG chatbot. So in that case, there is no need to use this kind of advanced vector database. So Pinecone is a very fast one. It is very efficient. Milvus is a lot more faster than Chroma. There is something called as Phase. This is also very fast vector DB from the Facebook side. Let me just show you. Phase full form. It stands for Facebook AI Similarity Search. Okay. And it's an open source library built by Meta for fast similarity search. So it's a really fast vector store. You can use this. So it depends upon your use case. If you have a less data, and you go with the chroma. If you have little more data, go with the phase. If you have maybe billions of vectors, go with the milliverse quadrant. And these are, of course, these are optimized for your production systems only. Whatever vector database we have the option in Azure, AWS, and GCP. So we are gonna work one by one with all of them, but you have to be a little patient, because I want to reveal one by one all of these features, not in just one go. Okay.
Yeah.
All right. Any more questions? So for today's class, let me just put it and commit it. All right. I think everybody is already having the link of the GitHub, but let me share it once again in case if anybody does not see it. All right, so I've sent you the link. How was the class, by the way? Are you guys able to enjoy?
Yes, Sachin.
It was
Awesome.
nice and understandable.
Because like I don't have any knowledge prior to this. Like I'm from data engineering background, but like I can understand, a little bit of everything. And also I'm trying to, playing around it. Like today, like as you said, like, there is lot many DB. So I'm going to try like all the data vector today. So let's see like how it behaves. Yeah,
Sure,
thank you.
sure. Yeah, no problem. All right, awesome. Okay, thanks everybody. Thank you for joining. We'll see you tomorrow.
Thank you. Bye-bye.
Yeah, bye. Good night.